A very good day to you, all my students. I am S.Adebayo. I will be taking you through chemistry, and the topic here today is oxidation and reduction, which is called redox reaction. Oxidation and reduction, which is called redox reaction. And under this, we shall be discussing the redox reaction itself, oxidation numbers of central elements in some compounds. We want to also look at the connection of oxidation number with IUPAC name, oxidizing and reducing agent and redox equation. If you cannot finish it in this class, we try and continue in the next class. Now let's discuss. Redox is a short form for reduction and oxidation. You can see the redox. The RED is from reduction and the OX is from oxidation. So when you hear redox reaction, is a combination of the oxidation reaction and the reduction reaction. So the two reactions are opposing. You can say they are opposite. One is an opposite of the other and complementary. And they occur simultaneously. Whenever an oxidation occurs, we must have had a redox reaction taking place indirectly or unconsciously. Because a material when a material oxidates, there will be another material which must have reduced. So let's look at the definitions of some of these terms that we use in redox reaction. And the first one is we want to define oxidation. Oxidation, that is, we want to talk about oxidation first and definition of oxidation reactions with examples. The first one, what is an oxidation? Oxidation in terms of addition of oxygen. We can define oxidation in several ways. The first way is when we define oxidation in terms of addition of oxygen. Oxidation is defined as the addition of oxygen or removal of hydrogen from a substance. Whenever you remove oxygen from a substance, that substance has been oxidated. Sorry, whenever you add hydrogen, whenever that oxygen to a substance, rather, whenever you add oxygen to a substance, that material or that substance must have been oxidated. Or whenever you remove hydrogen from a substance, you have also oxidated that material. So oxidation in terms of addition of oxygen is defined as the addition of oxygen from a substance or the removal of hydrogen from a substance. Any reaction where there is an addition of oxygen to a reactant, and that reaction is regarded as oxidation. And what are the examples? Look at this example we have here. We have 2Mg plus O2 giving you 2MgO. Now, you can see that a magnesium must have oxidated here. It's because a magnesium as Mg is 0. You can see the oxygen is 0. You can see in the MgO, the oxygen number must have changed and increased. Look at the second one, the carbon plus zinc oxide. And then we have the CO2. You can see the indirectly addition of oxygen is being done to carbon in this second reaction. You can see the carbon have taken up oxygen, and in the first reaction, you can see magnesium have taken up oxygen. Whenever an oxygen is being added to a substance, that material has oxidated. You can see that in the first equation, magnesium has oxidated, and in the second equation, the carbon has also oxidated just because they have absorbed or they have taken up or they have been added to by an oxygen. Oxygen has added to them. Now, in this reaction, oxygen was added to carbon, I think to form carbon dioxide, and also that is the carbon was oxidized to carbon dioxide. That's what we have in the second reaction. Now, let's define oxidation in terms of hydrogen removal. You know, I said it before that oxidation is defined as the addition of oxygen to a substance. So oxidation also can be defined as the removal of hydrogen from a compound. Whenever you remove hydrogen from a compound, that material must have oxidized. An example of this is the combustion of hydrogen sulfide. Look at the first equation. When you say a material combusts, maybe that means a material burns. Look at the H2S there, that's hydrogen sulfide plus oxygen gas. You can see that the hydrogen sulfide have turned to water there, and sulfur, as we can see that the oxygen has been taken up and the hydrogen has been removed from sulfur. You can see that sulfur that is present in the sulfide has turned to ordinary sulfur. the sulfide. You can say hydrogen sulfide, we have sulfur. So they can say hydrogen has been removed from hydrogen sulfide, you giving sulfur at the later end. So because hydrogen is being removed from hydrogen sulfide to form sulfur, you can say that sulfur there has been oxidized. And look at the second one. When hydrogen sulfide reacts with chlorine and the reaction forms hydrogen chloride and sulfur. Look at that. Hydrogen sulfide. Hydrogen is present there. You can see that sulfur now stay alone at the right, which means hydrogen has removed from the sulfur in this hydrogen sulfide to give sulfur. So in both reaction, hydrogen sulfide was oxidized to sulfur. The second reaction shows the oxidation can occur without the involvement of oxygen. So it does not necessarily that oxygen must be present in a reaction before it is oxidized. Whenever hydrogen is also removed, that material or that substance is also oxidized. Another way by which you can define oxidation is in terms of electron loss or loss of electron. Whenever any substance or compound loses electron, the the oxidation has said to have taken place. So oxidation is the loss of electron. And look at it, we have the sodium plus oxygen gas give you sodium oxide. You can see the loss of electron by sodium atom to form sodium ion in sodium oxide. You can see we have sodium ion in sodium oxide, and we have the sodium atom which is at zero, because any natural atom has the zero oxidation state. Is that zero? Any free atom like sodium or oxygen is right. We can see that whenever it has reacted or dissociated, we have it to be formed sodium oxide, and oxidation has taken place, and that means the electron has been lost from sodium to form sodium ion. Okay, so oxidation have been able to be defined in terms of the three. The three. First one, oxidation is defined as the removal of hydrogen. That's the second one I discussed. Oxidation also is defined as the addition of oxygen. And the third one is that oxygen is defined as the loss of electron. Oxidation is the loss of electron. Those are the three means. Let's also define reduction. You know, I told you that reduction and oxidation happen, they take place, the reaction takes place simultaneously. The reaction takes place simultaneously, which actually means when one is happening, the other is also happening. So let's talk about define the reduction. I also say that reduction is like opposite. Like both of them are, one is opposite of the other. So the definition of reduction is like the opposite of the definition of oxidation. So whenever you know the oxidation definitions, indirectly you have known reduction definitions. The first one, we said oxidation is addition of oxygen. Now, reduction is removal of oxygen. You can see there is opposite. And look at the equation we have there. Copper plus zinc oxide, giving you copper oxide plus zinc. Look at the zinc oxide there. You can see that the zinc oxide there has lost oxygen. Because we have zinc oxide getting to become zinc at the right. So zinc oxide was reduced to zinc. So that means we can say that the zinc has been reduced. Are we together? Yes, you can look at the addition of hydrogen too. That is the second definition. I define oxidation as the removal of hydrogen. Now, reduction is the addition of hydrogen. So whenever hydrogen is being added to a substance, that material has reduced. So hydrogen sulfide plus chlorine is an example. You can see hydrogen sulfide now. Hydrogen sulfide is having hydrogen. You can see that later the hydrogen has been removed from the sulfur and the chlorine has taken it up. So chlorine is reduced to hydrogen sulfide. You can see chlorine also, look at the chlorine there, is in a free state, and it has been reduced to hydrogen sulfide because chlorine has taken up, has added. We only hydrogen has been added to the chlorine. Don't forget, we said the addition of hydrogen. So a material, a substance that hydrogen has been added to in this equation at the right is the chlorine. So chlorine is the one that has been reduced. Gain of electrons. I also discussed that the oxidation is the when we have electron loss. Now, reduction is when never, don't forget, when the electron is being lost, that means there is a loss of electron. And reduction now in an opposite form is defined as the gain. When an electron is being gained, then we have the reduction has taken place. And look at the two examples there. In the first one, oxygen gas is reduced and gain electron, and we have H in the right to be sodium oxide. There's a gain of electron to oxygen there. There are 4 electrons that have been gained. Now, in terms of decrease in oxidation number, this actually I did not mention this under the oxidation. Whenever there is a gain, a loss of electron, there is an increase in the oxidation number. And whenever there is a gain of electron, there is a decrease in the oxidation number. So reduction is also defined as a decrease in oxidation number. So whenever any material experiences or any substance experiences a decrease in the oxidation number in any reaction, the substance must have reduced. Example here is zinc plus copper sulfate here. That is zinc plus copper tetrasulfate 6, giving you zinc tetrasulfate 6 plus copper. The oxidation number of copper here in the front, in the left, is from this copper here is +2 in the first at the left, and it has decreased from that +2. When it get to the other end, it becomes copper at 0. That do that any substance or any element at the free state, the oxidation number is 0. So copper at the right is 0. Copper at the left is +2. You can see there is a decrease in oxidation number. So reduction is defined as the decrease in oxidation number. Why oxidation is defined as an increase in oxidation number. We can also discuss oxidation and reduction in terms of addition of electronegative elements. Whenever any electronegative element is being added to any substance, such element has reduced. Whenever the electronegative element like chlorine, for instance, most of the group 8 elements are electronegative. Cl minus, Br minus, hydrogen minus, we have fluorine minus. They are electronegative because those are the most electronegative. The group 7, which are called halogens, they are the most electronegative elements. Whenever any of them is being added to any substance, the substance must have reduced. So we can also define reduction as the addition of electronegative element to a substance. Now let's look at the redox reaction. We said redox reaction takes place simultaneously, and let's talk about them and in terms of electron transfer. Considering all the reactions used as an example so far, we know or we have seen that both oxidation and reaction occurs together. Now let's look at the sodium. To sodium, look at the equation at the right there. We have first one, carbon reacting with the, look at the equation here. I want to try and zoom it off. You can see carbon reacting with zinc oxide, forming carbon 4 oxide plus zinc. Now, we can see that there is an addition of oxygen to carbon. Look at the arrow there. A carbon which is at 0 state, which is a free state at the left, has been, look at this video very well, look at the picture. This carbon at the left has turned to carbon 4 oxide. That means that carbon have taken up oxygen, addition of oxygen. So that process, the process of carbon becoming carbon 4 oxide, is an oxidation. And look at the zinc. It's carrying oxygen before, but later oxygen, when it gets to the right, oxygen has been removed. So that is a remover of oxygen, and that is more or less a reduction. I think you understand that. Now look at the second one here. We have 4 of sodium plus oxygen gas, giving us sodium oxide. Look at the sodium here. Let's look at the oxidation. Look at sodium. Sodium is at the free state. Sodium at the left comes together for the right side of the equation, has taken up oxygen to be sodium oxide. You can see that oxygen is being added to sodium. That's an oxidation. And look at the oxygen that is having at the free state there, oxygen as a free state there, 0, comes to what? Comes to, we can say it goes to also attach to, sorry, oxygen O2 there. You can say that we have the oxygen number of oxygen there is 0, and when it goes to the right, we can say that the oxygen number of oxygen is now what? Is now minus. You can say that there is a reduction, because there is a reduction or reducing in the electron loss of, there is a what we call gain of electron rather. We have from 0 to -2, 0 to minus, because the original number of oxygen says sodium oxide is I think -2, yes. Then it in the oxygen gas is 0. You can see there's a what? There's a gain of electron, just as when we have discussed the reduction as the gain of electron. That is really what I want to discuss there. Now, I want also to discuss the oxidation numbers of central elements of some compound. We have discussed this earlier on in our SS1 class. And how oxidation numbers or oxidation and reduction reactions, how are they used to determine the oxidation number and how a particular substance or compound is named. Oxidation number is the electrical charge, please, it's not change. It's the electrical charge assigned to an atom in accordance with some prescribed set of rules. Any charge that is being attached to an atom is the oxidation number. For instance, oxygen have oxidation number of -2 in some elements, in some compound. It takes -2, and that means that is the charge. Though it takes -1 in the oxochlorate 1, but commonly oxygen, most common rather, oxygen takes -2. Calcium takes +2 as the oxygen number. That is the oxygen number, and that's the charge that is being assigned to it. What are the rules that are used in determining the oxygen number? The following set of rules are used. That's number 1. The oxygen number of an element in an uncombined state is 0. I've been saying this all this while. Whenever you have any element that is not combining with any element, the oxygen state is 0. For example, oxygen number of hydrogen, oxygen, sodium atom in a free state or uncombined state with another element is 0. I've said about this before. I've talked about this before. I was mentioning some elements that when they are at free state, it has 0. Whenever element now combine, the oxygen number now has or change. Now, number 2, in most compound containing hydrogen, the oxygen number of hydrogen is +1, except in some hybrids, which is -1. In most cases, oxygen number of hydrogen is +1. When you see hydrogen, you attach +1 to it. In most cases. 3, the electron share between two unlike atoms are counted with more electronegative elements. For example, in water molecules, the electron are regarded as being with the most or more electronegative element. I mean, the what? The electron. So the electron, the electronegative element, and the one that is carrying negative sign, are the one that have more electrons. Thus, H2, each hydrogen atom is +1 oxidation state, and the oxygen atom is -2 oxidation state. What are the rules? So I think, yes, we are still continuing with the rules, rules of determining the oxidation number. The fourth one is that in most compound containing oxygen, the oxygen number is -2, except in some peroxide where it is -1. Hydrogen peroxide, sodium peroxide, barium peroxide. Whenever you have peroxide, it is -1. So, like I said before, hydrogen takes oxygen number of +1 in most of the reactions, except in some hybrid cases, and oxygen also takes the oxygen number of -2, except when we have in peroxide that it takes -1. Number 5 is that the oxygen number of each halogen, any of the halogen, whether fluorine, whether chlorine, whether it is iodine, bromine, all these halogens, the group 7 elements, the oxygen number is always -1. It's -1. Now, the next one is that the sum of all oxygen numbers of elements in a compound is 0. So this is really used when we are calculating oxygen numbers of elements. The addition of all the addition numbers of elements is 0. The addition. We're going to practicalize this when as we go further. The next one is that in simple ions containing one atom, the oxygen number is equal to the charge on the ion. For example, when you have Al3 plus or Na plus or Ca2 plus, you can see the charge, each of these ion, because any particular element that is carrying a charge is an ion. So the charge they are carrying is the oxygen number. So aluminum 3 plus is the oxygen number is 3 plus 3 there. And the copper 2 plus, the oxygen number is 2 there. So that is exactly what happened there. Now the last one, which is the last rule, is that complex ion. That is, a ion consisting of more than one element. When we have a complex ion, the oxygen number is the algebraic sum of all the oxidation numbers of all the elements in the ion. When we have, like, look at hydrogen chloride, now that's a complex ion because it consists of more than one element. Which we have hydrogen, we have chlorine. When we have H2SO4, now that is a complex situation whereby we have the combination of hydrogen plus sulfur plus oxygen. So whenever we have a compound consisting more than one element, we have said to have a complex ion. And how do you get the oxygen number? You algebraically sum all the oxygen number. For example, in the H2SO4, we sum oxygen number plus of H plus that of S plus that of oxygen. These are what we shall be discussing in our next slide. Now, so this will be the sign on the top of the sign on the ion and the of the same size. For example, in terms of system, you look at SO2 for SO4 2 minus. The overall charge is -2, which is oxygen number is. Now it is obtained as we look at the oxygen number when we have sulfur combining with oxygen in the equation we have there. It gives us SO4 2 minus. The oxygen number of sulfur ion, we have sulfur is +6. The oxygen number of oxygen is -2. So when you multiply 4 atoms there, we have 4 times -2. So we have +6 here, -8. +6 -2 will give us -2. So that's now the charge on the right hand side. So for other ions such as OH minus, NO3 minus, NO2 2 minus, NO3 2 minus, PO4, ammonium ion, the oxygen number of each of these elements I've said about, they are the charge. Look at it, in OH is -1, in NO3 minus is -1, in NO3 2 minus it's -2, in PO3, in PO4 3 minus is -3. That's in NH4, in NH4 plus it is +4. So the oxygen number actually is the number of the charge they are carrying. How do we calculate oxygen number of elements? The first one is the work example we find. Look at the same, we calculate the oxygen number of chlorine, or sorry, of chromium. In chromium, that is tetraoxochromium or tetraoxochromate 6. We are going to talk about that. Tetraoxochromate 6. And look at that, we're having a -2 there as the oxidation state of that radical. CrO4 is a radical. When we have more than one sort of elements that is carrying charge, it refers to as radical. Now we want to calculate the oxygen number of chromium in that. Basically, you know that oxygen number of oxygen is -2. In most cases, I told you, there are 2 oxygen numbers that are basically you must put at the fingertips when you are working. First one is that of hydrogen, which is +1, except in other ability situation, and that of oxygen, which is -2, except in the peroxide. And look at now, I told you that we have to add individual. You should let the unknown oxygen number of chromium be X. You know, it's chromium that we want to get the oxygen number. So we should let the oxygen number be X. And that's why we have X plus, that is in the second line after the solution, that is 1, 2, 3, 4. In the fifth line there, we have X plus oxygen is -2. We have -2 times 4 equals to -2. We are going to equate it to the charge. If there is no charge there, we are going to equate it to 0. That's the way we calculate the oxygen number. So by the time you solve that for X, we have 6. That's why we call it tetraoxochromate 6 in naming. So oxygen number is never written as a neutral number. We must write the oxygen number as either being positive or negative. You can't write the oxygen number when you get look at the pluses I wrote there. +6. I didn't see just ordinary 6. You must put a sign, whether it is a plus or negative. You don't just write it like 6 or 7 or something. You must put a sign. Look at this example. They said we should calculate the oxygen number of sulfur in H2SO4. Yes, in hydrogen there is 1 and oxygen there is -2. Those are the two things I said we should know. So let us look at 1, 2, 3, 4, 5 line. In the 5 line under the solution, we have 2 times, that is 2 of hydrogen. You know, hydrogen is +1. So then we have 2 times +1 because we have 2 of that hydrogen. Plus, we have let the, because sulfur is the main thing that we are looking for now, the same number. So we let it to be x plus O4. You can see O4, we have 4, that is 4 times -2 because oxygen number of oxygen is already -2. That's why we have 4 times -2, which is equal to 0. So here, by the time you solve, you can see the, so in the workings, we get our x, which is the oxygen number of sulfur to be +6. That is why we call this compound tetraoxo. That is from 4 oxygen sulfate 6, because the oxygen number of sulfur there is 6. What is the connection of oxygen number with IUPAC names? From all examples that we have considered so far, we have to note, or we must have noted that the names of most inorganic compounds reflect, and it's the oxygen number that determines the name. Wow, we'll look at the number of oxygen atoms in the compound that we have below. CO, I'm sorry for this, this is not written mathematically. This should be CO3 raised to power 2 plus. That's the way you write it in chemistry, and that is trioxo. You can see because it has 3 oxygen there, trioxo. SO2 4 minus. SO2 4 minus, they have 2 oxygen there. That's why we have, there are 4, sorry, SO4 2 minus. I'm sorry about that. It should be SO4 2 minus. And that is 4 oxygen. That's why we have 4 oxygen atoms, which is tetraoxo. And look at the Cl2O7 2 minus. That is, we have 7 oxygen. That's why we have heptaoxo, because hep is 7. So the formula of a substance is known. If we have a formula of substance, if it's even known, the IUPAC name can be written by calculating the oxygen number of the central atom used in the of central atom using the fixed oxygen number of the atoms, like oxygen, hydrogen, and the halogens I have taught you all about. There are some basic oxygen numbers that you must know, which is the for oxygen, which is -2, hydrogen +1, halogens are -1 as well. So for KMNO4, the oxygen number of potassium there is +1. For oxygen there is -2/4. And the central atom there is Mn. So we can find, when by the time you add K plus Mn plus 2 times 4, which is 2 times -2 times 4 rather, for oxygen, what are you going to get is going to be 7. By the time you calculate the oxygen number for manganese in this KMNO4, you are going to get 7. So that's why we call this one tetraoxomanganate 4. So it's 7 rather, tetraoxomanganate 7. By the time you are talking about that. So let's look at the following prefixes that are considered under the oxidation. There are some prefixes and suffixes that I want us to note. When you have a 1 atom, it is a mono. When we have 2, it is di. When you have 3, it is tri. When you have 4, it is tetra. 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. We are used with this. In this one, when we have SO3 2 minus, that is a sulfate 4. SO4 2 minus, that is sulfate 6. These are basic things we can learn by heart. MnO4 minus, that is manganate 7. I've talked about PO4 3 minus, that is phosphate 5. ClO3 minus, that is chlorate 5, and so on like that. These are the things I want to master and take at mind. I want to, because I will be testing you on this in the next. Look at the example. Calculate the oxygen number of manganese in KMNO4, and let's name the compound. So we should let the oxygen number of manganese be X. So in the K, we have 3 elements there: K, Mn, and O. The K is a metal which has an oxygen number of 1. Most times you look at the group they belong to. You can see potassium belongs to group 1, so oxygen number is +1. Calcium belongs to group 2. Oxygen number is what? Is +2. Aluminum belongs to group 3. The oxygen number is +3. In most cases, the group they belong to can give you a clue about the oxygen number. So by the time you have look at the calculation there, it's very simple and direct. The manganese there is 7. And that's if you want to now name it now. Look at that. You start from the oxygen side, 4 oxygen, that is tetraoxo. So we have potassium, rather, we have potassium tetraoxo manganate 7. Just because the oxygen number is 7. We are used with this in our SS1 class. Anyway. Now in summary, I want you to look at these evaluation questions, and basically if you have been with this video from the beginning, you must have learned how to answer these questions. I wanted to write this question down and make sure that you can provide answer to them after you must have read over or skipped through all these videos and noted all the points. These are evaluation questions that you can use to judge yourself if you have really learned or not. I will be seeing you later in our next video next week so that we discuss or we continue the topic of the redox reaction. I hope you have been blessed by the video. Thank you very much. Try and stay safe and enjoy your break. Thank you very much. Good day.